You should only be watching this video if you've tried this example for yourself. So either you've done it and you think it's right and you just want to check your solution, or you've got stuck. If it's the former, then whenever I ask people to stop the video and try a bit for themselves, just ignore me. Okay, so if you've had some trouble with this, I'm just going to give you an outline of what you need to do, and then you're going to stop the video and try it for yourself. Here's the equation. Just like with ordinary algebra, we can substitute in for the bits that we're told. We know what matrix A is and we know what matrix B is, so just substitute those in, and then use the ordinary rules of matrix algebra to try to make X the subject of the formula and simplify down whatever you get on the right hand side. Now stop the video and try that for yourself. This is what you should have done for part A. Substitute in for matrix A, 2, 3, 0, minus 1. Substitute in for matrix B, 4, minus 2, minus 3, 1. X, that's what we're trying to find out, and we can't do anything with the right hand side at the moment. The next step would be to multiply those two matrices together. So pause the video and then do that. What you should have got multiplying those matrices is minus 1, minus 1, 3, minus 1. So this is the next line of the algebra. Now you've got to think what you need to do to both sides to leave X as the subject of the formula. Same thing to both sides. Think about it, pause the video and then come back to me. This is what you should be doing. We want to get rid of that matrix on the left. So we multiply by its inverse. We've multiplied by that inverse on the left of the left hand side, pre-multiplied by it, so we need to pre-multiply the right hand side by the same thing. Now you should see what happens when you multiply those two matrices together. See if you can do the rest of this little bit, make X the subject of the formula while you pause the video. Those two matrices, any matrix times its inverse, would give you the identity matrix. So we get this. Right hand side, we haven't done anything with the right hand side yet, we will do. And then any matrix multiplied by the identity, multiplying by the identity doesn't change it at all. So we've successfully made X the subject of the formula by doing the same to both sides. We haven't finished yet, we've got to simplify that right hand side, so pause the video and see if you can do that now. We've reached this stage and now we just need to simplify the right hand side, but we can't do the multiplication until we've worked out the inverse matrix, so pause the video and do that now. What you should have got is 1 over the determinant, swap the elements of the leading diagonal and multiply the other two by minus 1. From this stage it should be very easy to work out X, so pause the video and do that. Multiplying those matrices, you should have got 8 minus 4, 16 minus 16, and therefore X equals 2 minus 1, 4 minus 4. If you've understood part A, you should be able to do part B for yourself, so pause the video and have a go at it now. What you should have got is this. Substituting in for A, that's 2, 3, 0, minus 1. Substituting in for B, 4 minus 8 minus 3, 6 times X equals the same right hand side. Multiplying these two matrices together we get minus 1, 2, 3, minus 6. And then remember that step, to get X as the subject of the formula, we need to remove that 2 by 2 matrix. and do that by pre-multiplying by its inverse. We're being very, very careful to do exactly the same on both sides, pre-multiplying on both sides by the same inverse matrix. And then you should remember this from the last time. Any matrix times its inverse is the identity. And the identity times any matrix, well, the matrix isn't changed. So this is how, exactly as in part A, we've made X the subject of the formula. So now it's just a question of simplifying that right hand side. Pause the video and do that for yourself. So now we've just got to find that inverse and do the multiplication. So we'll do that. The 1 over the determinant, right, the determinant is 0. If the determinant is 0, the matrix doesn't have an inverse. We call it a singular matrix. So in this case, the equation can't be solved. With the given matrices A and B, there is no matrix X which solves the equation. So there is no solution, since the matrix minus 1, 2, 3, minus 6 is singular. That's the end of the question, but I just want to talk a little bit about what you need to write in the exam. This sequence is extremely well explained on paper, but in the exam, if you missed out these 2 steps, you wouldn't lose any marks. It'd be good to have them in. It's good explanation. It shows you really understand what's going on logically, but you wouldn't lose any marks if you missed them out.